All right, hello everyone. My name is Timothy Lee Grant, and welcome back to another video where we are going to be exploring more Linux topics. So, today, one of the things that I'm kind of curious, and I have some notes on what I want to investigate today in these videos. So, one of the things that I'm kind of curious about is when I'm doing Python, sometimes I do sudo apt install and then a package. Other times, I do pip install and then a package. Hold on, what's the difference? Why do I do one in a certain situation and the other in a different situation? And what actually is those different situations? I want to figure that out. And I also want to figure out where do packages actually live and how does a package get initiated and all of this stuff. I want to figure out what are packages actually doing. That's one of the questions I have. The other one is about daemons. I want to figure out how daemons are working, how they're started. I want to figure that out. That one might be a little bit of a stretch goal. I don't know if we're gonna get to it in this video, but yeah, that's one of the things. And then maybe cron tab as well. I'm curious about that. So let me minimize myself, get myself a little bit smaller. There we go. I guess I can get a there. Okay, so what I want to do is let's investigate the first one about pip install. So I noticed that sometimes when I need to install on Linux for Python, I will need to do sudo apt install package. Oh, come on. Package name. Okay. Other times, I will need to do pip install. Okay. What exactly is the difference? And when do I use one over the other? Okay. So let's see what it says and let's try to dig deeper and deeper into this to figure out like what exactly is going on. So the difference lies in what you're installing and where it's being installed. Okay, let me make it a little bit brighter. There we go. Apt. Okay, so the difference between these two is what I'm installing and where it is actually being installed. The other thing now that I'm thinking is, well, hold on, where do virtual environments come into play with this? Apt installs system level packages. Okay, system level packages. Does that mean from the Linux distribution? Okay, so does that mean it applies to the entirety of my Linux device? Well, pip installs Python packages from the Python package index into your Python environment. Okay. So key difference between apt and pip, the scope. So when you do apt install, it does it system wide, including Python libraries. Okay. Pip is, as we can tell by the name, Python packages. Here, Python package index. So that's kind of what pip is doing. Okay. So apt is actually from Linux itself. It uses the binaries, library tools, requires sudo because you're doing it to the actual Linux machine, okay? Version, often older, stable versions. It's system global, which is why we have to do the sudo. Okay, so for pip though, it's only Python packages and it just installs the Python modules. Usually no sudo needed, latest version. Okay. So I also noticed sometimes I will get an error that I'm not allowed to, I forget what the exact error is, but I know that the way that I fix it is I do dash dash break system, and that fixes it. I can't remember what this was. I don't remember why I needed to use it, but let's investigate that. Okay, so use app when installing system dependencies. System dependencies. You need a package maintained by the Linux distribution. You want stability. Okay. Pip is for things like Python libraries specifically. Okay. So hold on a second. We're doing matplotlib. So there's Python 3 matplotlib, and this is a system-wide library that I can install onto my Ubuntu machine. Okay. And then there's also this matplotlib that would be installed somewhere, and we haven't figured out where it's being installed yet, where it's actually being installed and where it's being grabbed from when we run these commands. Well, I don't mean we know where it's being grabbed from, right? It's being, when you run the command, it's being grabbed from these locations. But I mean, when you're in your Python code and you import this library, where does that actually grab from? Where is this library stored? We don't know that yet. Okay, so I remember that, move this so I can type easier. I remember that in the past, I ran into an issue where I was unable to use one of those commands, and the way I fixed it was by doing break system. What was this, and why was it required? Okay, so the break system packages flag is used with pip. Okay, so it was a pip command that I ran into this problem. Now, it is used to override a safety mechanism that prevents Python packages from interfering with system managed packages. Okay, it's required when you're installing a Python package in a way that could conflict with your Linux system's package manager, like apt. Okay, I don't quite understand that. Let's see if we can get a little bit more clarity in the following things. Modern Linux distributions, like Debian-based ones, like Ubuntu, okay, use a protection mechanism called this to prevent pip from installing packages onto the system Python environment. Okay, so there's something called the system Python environment. What it is, how it's working, we don't know yet. This might be actually where we have to grab things from. So, apt manages system-wide Python packages. Pip installs packages independently from this PyPy location. Okay, mixing them can lead to dependency conflicts, broken packages, or system instability. So when you're trying to use pip install globally, you might see this error. Okay, so does that mean it's actually a lot safer to always use the system-wide one? No, because then I need a virtual environment, right? Okay. So what does this actually do? Using the pip install break system packages tells pip, I understand the risk, go ahead and install the package even though it might conflict with system managed ones. It bypasses the protection. Okay. So it's bypassing protection. The way that it's saying to do it is instead of using break system packages, it's safer to create a virtual environment. Okay. Activate it. Okay. Use pip install freely inside of it. So I guess I am confused on which packages will be system wide and which ones will not. If I am not using a virtual environment and I use pip install, where will this go? And what is its scope? I don't really later. Okay. It's a common point of confusion when working with Python or Linux. Let's break it down. Where does pip install go without a virtual environment? If you're not using a virtual environment, pip install will install packages onto your system-wide Python environment. Okay. So now it's giving me a location. So it's in the user's like folder, local lib python whatever 3 point something, and then distribution packages, and then this is the folder which my library will be going to. So I put a library package inside of this location, or some other location. It might be here, but if we're on Ubuntu, it's going to be here. This means the package is available to all users on the system. So if I have a Python program from here and a Python program from here, they live in completely different folders. They can both see that Python library, whatever it is that I'm installing on. For example, let's just say NumPy, right? If I'm installing NumPy, I do sudo pip install NumPy. Not sure if I need the break system yet. I think I do. But let's just say it works and it puts it in this location here. Now, both Python programs are allowed to use NumPy because when I run the Python command, right, that's how to run the command, you need to go onto the terminal and you say Python and then the name of the script that you want to run the Python with, and the kernel will say, okay, great, I'm running Python, and it looks for it knows where to look for packages, which is going to be here, and so then you can use that NumPy. Okay. It can conflict with packages installed via apt, which also manage system Python packages. Okay. So does that mean that they are in a separate location, and when Python is called, it looks at both locations? That's a good question. Okay, so number one, this, I'm gonna copy this and say, does this imply that it will store it in a different place for the pip and the apt, and that when I run the Python and then main.py command, the kernel, I don't know if it's actually the kernel, will run Python and look in both locations and then get confused because it sees two packages or modules or libraries. Which one is it? Which terminology is correct? In the two separate locations which satisfy the import statement. Use NumPy as an example to illustrate it. Okay, we're going to do that and then come back up to here. So we do this, and now system-wide versus user-specific versus virtual environment. So this might be a bad thing to admit, but I don't use virtual environments, not because they're bad, just because I don't know how to use. It's not something that I normally. It was never something that I was forced to do, and therefore it's easy to avoid doing it, right? But one of the things about becoming a good software engineer and becoming a good engineer in general is kind of to try to find and face those things that you were never forced to do, but you know will make you a better engineer in the long run. So I want to obviously go in that direction of doing the virtual environments, but so far I just haven't used them very much because I've never been forced to, number one, and also it's really easy when you're being asked to just develop something, develop it, and especially because I'm like the only software, firmware, embedded systems. I have a very broad spectrum of what I do. And so when you're constantly being asked, like, oh, do this, build this project, and they want the result really fast, it's like, okay, well then, here, I know how to do this. Just go. And, but anyways, sudo apt install. It's something that I definitely need to practice on, pay attention to, and eventually improve. So, but that's why we make these videos, is to actually improve ourselves. So sudo apt install, it goes to this location here, the user lib, and then Python distribution. Okay. Wait, wasn't that the same place up here? User, this is local. Oh, here. User local lib. Okay. Pip install user. Local lib Python. Environment, so it creates its own environment here, and then within this environment it has a package. Okay, Python 3, and then we can set that there. So best practice is use pip install user if you don't want to mess with system packages. I've never seen this user flag. Local lib. So it's just not in the user, it's in the root directory. Okay. Use a virtual environment for projects. This isolates dependencies and avoids system conflicts. Okay. Using sudo pip install, unless absolutely necessary, okay, can overwrite system managed packages. Okay, so now we're asking about, like, how does this work with NumPy? We're kind of asking it to give us some examples using NumPy so that we can understand this a little bit more. So yes, I'm on the right track. Let's break down how NumPy actually gets installed in these two situations. So first off, package. We're going to talk about the terminology because I didn't know what to use. I said, where is it? Is it a library, module, or package? Okay, so hold on, let me get some water. Okay, we're back. So, package, a collection of Python modules bundled together. Okay, so a package is modules together. Now, so module is more singular. Okay, so module is a single Python file. Okay, so we can have a whole bunch of Python files. That makes kind of a project, and a project is a package. Okay. Yeah, that makes sense. Library is a general term for reusable code, can refer to modules or package. Okay, so what we actually want is package. That's what we want. Okay. So now, where does apt and pip install this NumPy? So sudo apt install python 3 NumPy. Now, I'm glad I wanted to kind of force it to do this right here. Because look, the names are different. Python 3 NumPy and NumPy. But in my Python program, I'm not going to say import Python 3 NumPy. I just say import NumPy. So let's say that I didn't do this one, okay? And instead I did sudo apt install and then this Python 3 NumPy. But in my Python program, I said import NumPy. Is it going to break it? How does it actually associate those two names together? Okay. But they are in different directories. One is user lib python 3 distribution packages NumPy. The other one is user local lib python whatever and then distribution packages NumPy. So it's in a different location. These are different directories, but both are in the Python's system path, okay? The list of places Python looks when you do import NumPy. And look, it says import NumPy, not Python 3 NumPy. What happens when both versions exist? Okay, so Python 3 main.py, and inside we have this import NumPy. Awesome. Python searches the system path in order. Okay, so meaning in an ordered manner. First, second, third, fourth. If both versions exist, it will load the first one it finds, which might be the one from pip, even if apt installed a different version. Okay. And this causes version mismatches, unexpected behaviors, broken dependencies. Okay, so the main problem that this seems to come up with is just like dependencies of the libraries, which, okay. I know I'm supposed to say it's a big deal, but it doesn't seem like a big deal. Okay. Like I use a slightly older or newer, I don't know. Then why don't I just go and update it? Okay. So if I do this and it's version here and then I later run pip install NumPy and I get this newer version. Now NumPy exists in two places. Python loads the pip version first. a system tool expects NumPy 1.7 might break. Okay, fine. I don't. Okay, okay. But I think I'm getting the general idea. So when I do the virtual environment, it just creates this new folder that has the paths to the variables or to the packages. And from that, when I do Python, when the virtual environment is activated, Python looks for those packages. Okay. Otherwise, it will go in and try to look at the different ordered locations in the Python path and see if it is able to find a library that matches, and then it just selects the first one in there. Okay. That kind of makes sense, though. At least I'm not confused about it anymore, right? Like, at least I am understanding that point. Okay, so the second thing that I want to do is, I'm curious about how do I get packages offline? In specific, what if I have because what I'm thinking is I have this Raspberry Pi. What if I don't want to connect it to the internet? What if I just want to just take my MacBook here and copy over a file, copy over all of this, the project that I'm working on, and I want the packages on it, pre-installed. I know that you can do this with C#. How do you do this with Python? And what's going on with that? So if I have a Raspberry Pi, which I don't want online, I do have a MacBook which I am developing a Python project in. If I want to transfer over the entire project to my Raspberry Pi, how do I deal with those packages? I know that there's something called like wheel files or something like that. I don't know if that's where it's going to go. And the other thing is, if my laptop is Mac, it's one operating system, and this is a Raspbian, like I believe it's Debian, right? Linux system, the packages are not going to be the same. So how do we deal with this? Because in C#, what you have to do is like .NET publish and whatever it is, like you have to give the hardware architecture that you are trying to publish your project for. And then you're able to take all of those files, put it on, and there you go, it works. Well, okay, how do we do it here? So, what I can do is use pip to download packages without installing them. Okay. So we make a directory offline packages. Pip download. I believe that means recursively. I believe that R is for recursively. Requirements.txt. Offline packages. Okay, so in requirement.txt, it will specify all of the libraries that we need. Okay. This will download wheels. Okay, yep. Or tar gz source files into the offline packages folder. If you don't have, you can create one from your current environment. Pip freeze. Wait, what? There's a lot going on here, and I don't know what's actually happening. Okay, so copy the entire folder to the directory on the Raspberry Pi. So yeah, we use SCP. That's fine. On the Raspberry Pi, install the packages. So no index is going to say, hey, don't look online, look locally. And then find links is going to be, tells Pip to look in the current directory. Okay. If your Pi uses a different architecture, yeah, make sure the wheel files you download are compatible. You can use pip download or similar Pi device with internet. Okay. No, I don't want to use a similar device. I want to use my MacBook. That's part of the question is I want to use a different architecture and I want to put it on my Pi. Use platform and Python version. So pip download and only binaries equals all to get compatible wheels. Okay. I don't quite understand how this works. When I create a folder and then do a pip install, you said that it will download the packages in this location up here. Which will not be in the folder which I have just created. So, am I reading that right though? Because this is just the name of it. It's not telling it to actually do that. Maybe it's this D flag, which is like destination maybe, which is to this directory. Okay. So why would the files appear in the directory? Okay. Why would they appear in the directory? And what? And I do want to use a different architecture as my MacBook to get the files online. Okay. if you don't have, you can create one from your current environment. Can you tell me more about what you mean when you say this? I have no idea what what's happening here. Pip freeze. I don't understand those commands. Those commands or what it is doing or how it helps. Okay. There's a lot I don't understand with that one. I understand here. I understand that's just copying over the files. That's fine. Okay, so now we have to do this here. Okay. Can you also explain this? All right. So when you use pip download, is that what we did? Oh, I didn't say install. Oh, my goodness. I saw pip and my brain just skipped over that download. It's not install, it's pip download. Okay. It saves package files onto your chosen folder, not installs them. Pip install installs packages to Python system or virtual environment. Pip freeze arrow sign text or requirements.txt command records your current environments package, and pip install installs. Okay, so let's kind of go down one by one. So pip download R, requirements.txt D offline packages. Pip download does not install anything. Okay, it downloads the raw files, which is going to be a wheel file or a tar.gz, onto the folder, which is the one that we just created. These are portable and you can move them to the Raspberry Pi. It's different than pip install. So now, this one here, pip freeze with the arrow, lists all currently installed Python packages in my environment. So I've already created an environment. Saves them into a file called requirements.txt. That's actually really cool. So I can just create a text file by using that command right there. And I'm guessing that this arrow means like redirecting the output. So I do pip freeze and that generates all of the packages which are currently used in my environment, and then outputs, or like sends that output to something which is called requirements.txt, and if it doesn't exist, it creates that. Okay. Interesting. That's actually a really useful command right there. Okay. This file is useful because it captures your project's dependencies. You can use it to reproduce the same environment on another machine, like your Raspberry Pi. Yes, I agree. That's pretty cool. And so for pip freeze, will this capture things which are installed in both the folders for pip and apt? I don't think so. All right, so pip install no index. So this says don't look online. Find links at the current directory, which means that current folder that we're in. And requirements.txt. So don't use this pi, so don't use the internet. Look at the current directory for packages and install the package listed in this text document. Okay, now since my MacBook is x86 or x84, and my Raspberry is ARM, what I need to do is run pip download or similar. Okay, so I can do pip download numpy, and then say platform is Linux ARM71. Where does the 71 come from? I'm not quite sure. And then Python version 3.9 binaries. Okay, so I can run that command. Let's see. What would happen if I had a virtual environment? Okay, I'm not gonna try to fix it. I'm just gonna do that. Okay. So, what does pip freeze capture? Pip freeze installs or lists installed packages that are visible to the current Python environment, but only those installed via pip or are pip aware. So it will capture packages via pip, whether system-wide or user-specific. It may not capture packages installed via apt unless they are also registered in pip's internal database, which many are not. So if you install NumPy via apt, it might not show up in pip freeze. Okay, if you install NumPy via pip, it will definitely show up there. Okay, what happens in a virtual environment? If you're inside a virtual environment, pip freeze only shows packages installed within that environment. It ignores system-wide packages. Okay. Okay, fine. Do we answer that question? Yeah, we answered those questions. Okay. So the next thing is, what are daemons and how do I create and enable them? So I know that these are like services that you're able to run within Linux environments to be able to like do tasks. They're not like they're not like scripts that you run, but they like enable the hardware to be exposed, I think. I'm not sure. Okay, so daemons are background processes in Linux that run independently of user session, often starting at boot and managing system services like networking, logging, and scheduling tasks. Yeah, so more of the hardware kind of enablement. You can create and enable your own daemons using a script and a systemd service file. Okay. So a daemon starts automatically or manually, runs without direct interaction often ends in .d, or in something D. So like SSH D and then system D. These things are daemons. So how to create a simple daemon here. I can create a Python. Oh, I didn't know that I could create it from a Python script. That's kind of interesting. Okay, so import time while true with open some kind of text, okay, as F, and we write to that text the time. Then we sleep for a minute, and then we write to that file. So this program is just going to keep running, and every 60 seconds it's going to log the time into that file, okay? So then what we can do, create a systemd service file. All right. So now I have already looked up what systemd is, and that is process ID number 1. It is the first process to be spun up from the kernel, and it is going to, I believe, create the other processes. Okay, so create a systemd service file. So maybe I'm just telling systemd, hey, I want you to start this process as well. So unit time logger daemon, okay, service, and then I give the location user bin python 3. So is that the location of here? Oh no, this is the location of Python itself, like the Python command. Then this is the location here of where the Python script is. And then restart always, user is user, then installed. Okay, fine. Interesting. And then I can do sudo system control daemon accept reload, and then enable timelogger.service. Start. Okay. Interesting. Okay, so I have a Python in the example you gave to me. There is a Python script and another file which is a service. Okay, interesting. So this is a dot service, and then system control daemon. Okay, so I just need to do those commands, and then I enable that daemon, and then it will perform this every time on startup, I believe. Okay. So what about if I have a daemon that I downloaded from GitHub, and I want to use that to be a daemon. Okay. So if I've installed one and want to run it as a proper Linux daemon, I need to integrate it with this systemd, which again, systemd is the thing that starts all processes, okay, to manage its life cycle. So here's how you do it step by step. Okay, so I do the clone. Okay, great, that's awesome. Gets it to my machine. And then place the main executable file somewhere stable. Okay, it's just an executable file. I need to make it executable by doing the change of like permissions to be executable. Okay. Then I need to go in and create a new service file. Okay, so I need to create the service file. That might be where I was making mistakes. I didn't create a service file. Okay. Interesting. So then I need to create my own service file. Okay. Yeah. And then enable and start the daemon. I can do that. Awesome. Okay. Kind of understand it. Kind of. Next question is, we're talking about cron tabs. So I want to say, how can... So I'll say, what about cron tab if I have a Python program that I want to run on startup of my Pi? Should I use the cron tab to run it? Okay. And then the other thing is, if I am using the cron tab, but I don't see my Python script run using what's the command? ps aux and then grep main.py, kind of like that. Is there a way to see if it was even attempted to be ran? And if so, can I see the error which occurred? Okay. Let me take a sip of water again. Alright, so yes, you can use crontab to run Python scripts at startup on a Raspberry Pi, but it's not always the most reliable for startup tasks, especially if your script depends on network, hardware, or other services that might not be ready. Okay, so to run a script at boot, you'll add a line like this. So at reboot, we want to do Python, the Python command, then the python.main, okay, and then directed to some kind of log. Okay. To edit the cron tab, I know how to edit the cron tab, that's fine. If I don't see it here, I can check that log that I just created. Okay, fine. That makes sense. Okay. You can also check system logs. So grep cron. Make sure that I added the executable permission. Use the absolute path. Python is available here. Check which Python. Okay, fine. And then I do want to explore using this topic that I just said there. But I also kind of want to explore this. You called this a system log. Can you go into more detail about what a system log is? Okay, that's number one. And okay, so I'm gonna break this up into 1, 2, 3. So 1, then we're gonna get 2. Can you explain this at the end of the command? Okay. Number 3, which is going to be so why is there 2 here? Why is there 2 here when your last command only had 1? And let me give it the last one so it knows what I'm talking about. Where did that go? I know we saw it. Okay. So now number 4. So we need to make sure, yeah. So okay, how do I do this? How do I do this? It's kind of, whenever I do this, it does its balancing, so I'm just gonna let it do its balancing. That way I don't need to read it while it's bouncing up and down. Okay, I think it finished. Okay, so what is a system log? A system log is a file where the operating system records events. Okay, because I know this from, what is it, dmesg, and then you can do the watch flag and you can see the system logs itself. So that's like kernel logs, I believe. And so that's why I was a little bit confused here. So a system log is where the operating system records events, messages, and errors from various components. Okay, like the kernel. Awesome. Services, daemons, applications. So on Debian, and yeah, so it is, even our Raspbian is a Debian device or operating system. Okay. Yep. I thought so. I was like 90% sure. It includes, okay, so this system log here, so var log system log, it includes the cron tab, systemd services, kernel events, networking activity, hardware drivers. Okay, wow, it has a lot. So I grep cron. This filters for lines related to cron jobs. Awesome. Okay, so what does this mean? The 2 arrow and sign 1. Okay, so this is shell syntax for redirecting errors. 1 stands for output, the std out. Okay. 1 stands for standard errors. And then the arrow sign is redirect. So here, means redirect standard errors to the same place as standard out. Oh, okay. This appends both output and errors to the same log file. Very useful for debugging. Okay, fine. Why use one? This one overwrites the file. This one appends to the file. Ah. Okay. Here, overwrites the file. So if you use... Oh, that doesn't quite work. If you use 2 of the arrows, that means append to the file. If you only use 1, that means overwrite the file. Okay. So, how do I use the systemd? To run Python scripts at startup using systemd, follow these steps. Create your own Python script. Yep. Make sure it's executable. Yep. Create a systemd service file. Okay. Paste this. Okay. So we have a systemd service file, and then enable it again using that system control. That's the exact same thing that we did up here. Okay. So it's like doing a daemon for the actual... It's essentially what we just did. It's just creating another daemon. I'm running the entire Python script as a daemon. Huh. Okay. Main service, okay. And then I can check journal logs. Huh. Interesting. Okay. Okay, well, I feel that I learned a lot in this video. Hopefully you guys learned a lot as well. Hopefully we found some new topics that we didn't know before, and now we do. And so I'm going to take a little bit of a break. I'm going to probably get something to eat a little bit too. And I might be back with another video today. I kind of want to do another video. So yeah, I think I'm going to do that pretty soon. If you want to subscribe and join me on this journey of becoming a better engineer, and I would love to have you along for the journey. So subscribe if you want to. I hope everyone is having a wonderful rest of the day, and I'll see you guys very soon.